Hello everyone, this is a quick summary of 17.1, detecting and measuring subatomic particles. Now we have several ways in which we detect subatomic particles. Some of the more common ones include a cloud chamber, which contains dust, free air, supersaturated with vapor from a liquid, such as water or ethanol, and charged particles beat through it. They cause the vapor to condense, and therefore we can see kind of where that particle is going. A bubble chamber contains liquefied gas. It's verging on boiling, so it's right at the boiling temperature. As charged particles go through, it will actually vaporize the gas into tiny little bubbles. So you've got kind of like almost a liquid gas. It's like right there, but it still stays tuned. Now, neutral particles and electromagnetic radiation don't actually leave tracks in these chambers. They'll go straight through because it's based on the actual charge of the particles. Now, if an external magnetic field is actually applied to these chambers, whether a bubble chamber or a cloud chamber, you're going to get the circular pass. And we'll just take a look at an example of that here. We've got 4 different types of particles going through. Now, in this case, because we've got the dots, the magnetic field we know is out of the page, so your pointer finger is out of the page. Now, the thumb, which is directing your velocity, the initial velocity is going to the left. And you're going to do this with both hands, with your pointer finger pointing out, your thumb pointing to the one side, and you're going to notice that your right hand, the middle finger points down. Where your left hand, the middle finger points up. Okay, so given the placement of thumb, pointer, and hands, the right hand shows positive particles, a force down on positive particles, and a force up on negative particles. And so we can safely assume that particle 2 here is a positive particle. Number 1 here, and 3 we can both assume are negative. However, in this case, because we've got 2 different radiuses, we can determine the fact that they have 2 different masses or 2 different charges. Now, so this one will either be lighter or have more charge. We do not have the amount of information necessary to determine which one that is, but this could be either have more negatively charged than this one, or this could just be lighter than this one and therefore affected more by the centripetal force. So this one, number 3, is going to be heavier or less charge. We don't know which, because we don't know about the mass or nature types of charge. But we both know that they're negative, and that number 1 needs to be lighter or more charge. Now, if we think about that, Fc is equal, because it is a centripetal force that causes us to move, or mv squared over r is equal to qvb. mv squared over qvb, one of those cancels, is equal to the radius. So the radius, more massive particles are going to have bigger radiuses. Higher charged particles are going to have smaller radiuses. Number 4 here, it goes straight through, and so this is going to be your uncharged particle. Okay, take a look at this one on the side here. Give it a try. Pause the video, give it a try, and then we'll come back to it. Okay, so as you've come back to this, you should have figured out that, again, the X is showing now that the magnetic field is, which is your pointer finger, is going into the page. Your thumb, which is the velocity, is pointing to the left of the page. And we see forces going down and up, but this is going to be from your left hand, and so indicating a negative particle. This is your right hand indicating a positive particle in terms of your middle finger. And so we know that this is the positive particle and this one is going to be the negative particle. To determine which one is moving faster, we would need to know that both these particles had the same mass and that they had the same magnitude of charge. Right? And again, the reason for that is simply because if that centripetal force is caused by the magnetic force acting upon them, or mv squared over r is equal to qvb, then mv over qb is the radius. The magnetic field is the same for both, so we're good there, right? But if we want to figure out this, we need to have these set as being solid. And so those are the answers. Again, hopefully it helps.